We are recording, lights are on and off.
Yeah, everyone's it.
Yeah.
No, it's
No
good.
one wants to see me. People want to see the slides.
Yeah, it's good.
I'm wearing flip-flops, for Christ's sakes. Alright, so I'm here to talk about Realtime and Go, and we're going to be doing 2 talks in one, 2-for-1 deal. We're also going to be talking about getting rid of frameworks and embracing tools instead. My clip is not working. There we go. Quick disclaimer up front, I don't represent the entire Go community. I am not the smartest person in the Go community. I'm probably just the loudest person in the Go community, which is why I'm talking here today. Quick overview of who I am, which apparently broke at this lower resolution. That's interesting. I'm Patty Forn on Twitter. I'm Patty on app.net. I work for IronO as a developer experience engineer during the day. At night, I work at Second Bits. I'm a little bit like Batman, except instead of beating up bad guys who like rob little old ladies, I end up beating up users who get mad at me for creating open source software. People actually do that. I do write Go, so I'm a member of the Go community. They call us Gophers because everyone needs a name. There's like Rubyistas, there's PH Prisoners of War. This is actually a talk that is going to be presented in France next week. They're bringing me to the Real-Time conference in Europe to give this talk. So I'd love any feedback you have. There's my email address. Please be nice. I will cry in your email inbox, and all your other emails will get wet, and it's just going to be an unfortunate situation all around. Go is a language from Google for people that don't know. Anyone used Go before? Hands up. Okay, anyone that I haven't directly converted used Go before? Oh, that's sad. All right, Go is a new language created by people at Google. Ken Thompson, Rob Pike, a bunch of these people formed a Go core team, and they made a better C from the guys that didn't bring you C++. That is not an official slogan. That's just us being snarky. It's compiled, it's statically typed, it's fast, it's elegant, and it's concurrent. And we're going to go through those one by one. Compiled. This is actually how you build a Go program. It's really saying you just enter the directory and you type go build, and it builds it, including all of its dependencies, creates a single binary that you can deploy easily, which is really nice. It is statically typed, but it's without the stuttering, so like when you do Java, you end up saying the word int like 6 times if you want to get an int variable. Here it's got type inference, so you just do, this is our initialization and assignment character here. So here we're initializing x to an integer that's value is 1, y is being initialized to a value, a string whose value is hello world, and z is being initialized to a map with string keys and integers values. And the value for A is 1 and B is 2. Very simple stuff, but it's a very clean way to get static typing in a language. Go is fast. One of its core premises, like one of the core driving factors behind it, is it's supposed to be fast when compiling and when executing. So it's getting faster. The Go 1.1 is like 30 to 50% faster for some programs when executing, but compiling is a nearly instantaneous thing. We actually had somebody complaining in the mailing list earlier because when they were compiling this binary with like 60 dependencies, they're like, yeah, Go 1.1 slowed it down like noticeably. It's taking like a second now to compile this. But the story behind Go is that Rob Pike originally, when he was compiling C++ for one of Google's projects, while it was compiling, like in the 45 minutes to an hour he had while it was compiling, he's like, gee, what should a language have? Because this clearly is broken. I shouldn't be waiting this long for this project to compile. And that's kind of how Go got started. Go is elegant. This is a quote right from their FAQ. Old programs read like quiet conversations between a well-spoken research worker and a well-studied mechanical colleague, not as a debate with a compiler. It's from Dick Gabriel, but I think it's really telling that they include this in the Go FAQ because Go is, it's trying really hard to be elegant, not in how you code, but in how you convey your ideas. The focus is really on making your ideas clear and concise so that when people read through your code, it's actually obvious what it does. So there's not this big focus on one-liners like in Ruby or Python. There isn't like a bunch of abstract or static factory classes that you have to implement in a certain order and kind of set up like a Rube Goldberg machine before you can get to what you want. Everything tries to be really straightforward. The obvious way to do things in Go is usually the correct way to do things in Go. And it is one of like the core features of Go is that it's a concurrent language by design. This is kind of a maxim we embrace in the community, and that's don't communicate by sharing memory, share memory by communicating. It's the idea that you shouldn't be accessing shared resources as a way for 2 processes to exchange information. those two processes should instead exchange information, and that's how they share resources. And it's kind of a different way to approach concurrency than a lot of the less concurrent languages take when trying to bolt on concurrency. So why is Go real-time? There are some things that make for nice concurrency support, or for nice real-time support, which are Go routines and channels, which make it nice and concurrent. There are some things that just make it a nice language to write with, the interfaces, a great net HTTP package, and easy deployment. And there's one thing that really makes like every language needs to have to be fun to work with, and that's a great community. Go routines are like cheap threads. They're the building blocks of concurrency. Does everyone know what I mean when I say concurrency? I'm using the computer science term here, not the bandied about by other languages term here. All right, nobody's raising hands. So, difference between concurrency and parallelization is that concurrent things are able to keep track of many processes at once. They're not necessarily executed in parallel, but the idea is that you're separating out the concerns of these processes so they don't step on each other's toes and collide with each other. Parallelization is when you have these things happening at the same time. It's possible, every parallel program needs to be concurrent, but not every concurrent program needs to be parallel. Go routines are basically the processes in that model of concurrency. They're the things that are happening that you want to keep separate. And these are really, really simple to start up. You define a function, and then you use the keyword go, and you run the function. And then you run another function, and that kind of sets it off into a different thread, if you will. They're not quite threads, they're a lot cheaper to implement and run. So here you're going to see hello world printed out as you would expect. If this wasn't run in a Go routine, then it would just say world, 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 hello, 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 hello. Oops, going the wrong way here. Channels are communication that just makes sense, and I put a trademark mark there that's not actually trademarked. They're just a way for you to pass information between two of these Go routines. They're the way to communicate, basically. So a channel is just a type, so you implement a type chan, and then the type of the channel, which is an integer in this case, and then you send on the channel. So here's sending on a channel, or sorry, here's receiving on a channel, here's sending on a channel. You pass into the channel what you want to send, so here we're sending an integer onto C. And this is really interesting. When you receive from a channel, it blocks that Go routine until the channel has a value. You say, I need a value for X, and I'm just going to wait around until someone gives me a value for X. So here we're receiving the value from the channel, and then assigning it to X, and then we're printing X. So here's a way to do a quick sum in a different channel, different Go routine of all these integers, and print it out, but concurrently. Interfaces, they walk like duck typing and quack like duck typing. Somebody yesterday said that this is strongly typed duck typing. So you're able to define a type that is defined by what it can do, which is an interesting concept. So here we're creating a friend interface, and that's any type that can say hello. So we're creating a duck type, which is just a string, and we're defining say hello for it, and that's just going to say, hi, I'm a duck, and my name is whatever. We're defining a goose type, and the goose type is just going to say, hi, I'm a goose, my name is whatever. But then we can do things like creating a slice, which is like a list in Python almost, of these different types that all implement the say hello, that implement the friend interface. And you just go through it, and you can have everyone that can say hello at that point. So you can interact with this friend type, and you say hello on it without any type conversion or anything, because for it to be a friend type, it has to be a say hello. And this is all checked at compile time. None of this is checked at runtime. But again, it's just like instantiating any other type here. And this is a lot different than, for example, Java's interfaces, because you don't have to go through and manually declare everything that you implement. You just implement it and move on. The net HTTP package is the only web framework you'll ever need. This is a basic server in Go. And a lot of the Go servers that are in production, including the Google Chrome download server, including there are several NTP servers that are written in Go. They all are just extensions of this. You define a server, which is something that just fulfills the serve HTTP interface, and then you tell it what to do when it does that. You can build this out so you get URL muxers that call specific functions, and there are built-in interfaces for that as well. Then you just run your server, and you list on localhost 4000. This is going to reply to every request with the word hello. You can see that the HTTP response writer is an interface up there. So you can wrap that in a JSON encoder, a BSON encoder, XML encoder, really whatever you want to do with it. Gzip it, send it through Speedy. It's anything that allows you to fill that writer interface, which is kind of why interfaces are so powerful. It makes it really easy to plug and build Go packages. Another thing about Go is it's got easy deployment. You compile it to a single binary. I seriously just SCP my binary to a web server, and that's my deploy process. Start it up with God or Ubuntu's init, and just let it run. And that's really how you deploy Go packages, which is a great kind of shift from Python, for example, where you got to set up your library and install your modules. Ruby, you got to set up your environment, you got to set up the web server. Here you seriously just take the binary and run it, which is kind of a weird thing to web developers, and it's a kind of old hat thing to system developers. And finally, our community. We are exactly the kind of people that choose Gophers as mascot. We've got a Google group that people like Rob Pike and Ken Thompson hang out on. By the way, if you've never had a computer legend explain to you exactly why you are an idiot, you really need to try it sometimes. It's a great humbling experience. It was like, hey, my code's not working. And Rob's like, well, and it's like, shouldn't you be like, you know, making self-driving cars or fighting the robot apocalypse or something? But Rob Pike, yeah, just hangs out on the Google group list. There's a Go Nuts on Freenode. I personally am not an IRC person. I don't know if any of you are. It's pretty active. There's Google Plus community for Gophers, and there's a Golang hashtag on Twitter. You can also follow the Go Nuts account, which is run by one of their lead evangelists, Andrew Durand, who's a very cool guy. Kind of what I want to talk about today is how we can use this. This is real-time technology. It's got concurrency built in. I think real-time technology needs concurrency because at the very least you've got something that's generating these events, and then you've got something that needs to tell other people about these events using WebSockets, using long polling, using Socket.io, using whatever you're using to push these events out. You need to tell somebody about it. So you need to keep these two processes separate. So I think Go is a really good choice for it, and we have pretty good technology in place for this. We have WebSocket libraries that are supported officially and unofficially. The community built one, and the Go team built one. We have a Speedy library. We have Socket.io library. We have a Pusher.go library. But these are all sort of solutions. WebSockets, the official library at least, it does support RFC 6455, which is the WebSocket standard. It does have the client and the server in a single package. You can tie into the HTTP server that's built in naturally, and it can be controlled using channels, which is like the best thing ever. You're like, hey, I want to send a message to it. I'm just going to put that message on this channel, and the other person will take care of it. And that's pretty cool. But it has some problems. There's no support for HXC 76 or HXC 75, which means that if the user doesn't have the absolute latest version of their browser, only Firefox and Chrome are going to work with it. It doesn't send pongs in response to pings, which is part of the WebSocket standard. It doesn't do that automatically for you. It doesn't send a close message automatically for you. You can't limit the size of received message, so it's possible for somebody to chew through all of your memory on the machine with a single WebSocket connection. You can't open stream messages, and you can't specify the I/O buffer size. So these are all kind of problems. But there is good news. The good news is all this is fixed. Gary Bird, an awesome gopher in the community, created a WebSocket package that fixed all of this. I mean, yes, it's not the official one that's packaged with Go, but it does have the fixes. I wish it were the official one that was packaged with Go's. And there is bad news, because not everything's fixed. Speedy, for example. Speedy was used by the Speedy group in their compliance test suite when it was being originally developed. It did fully implement Speedy 3, so they've got the entire thing there. But there's not like it's kind of like, hey, we built the building blocks of this, and then we're not going to tell you how to use them, we're not going to document them in any way, we're not going to do tutorials. It's got package serializers and deserializers, but it doesn't have a way to plug in to the native HTTP listening. So you can't do like a straightforward server using it yet. There are some community-built packages for all this, but they don't have much in the way of documentation either, and the community hasn't really selected a standard one yet. We haven't done the Pope thing where we send up the puff of smoke. So it's hard to know which one's going to be supported and continued in development. Socket.io has a clean API and a good example. This is a library for it. It does support WebSockets, Flash sockets, long polling, multi-part string, and ActiveX HTML file. Basically, if they have any browser used ever, you're going to be able to use Realtime with their browser. Except it's not updated for Go 1. Go did this thing where it didn't standardize the specification until Go 1, which was released in December 2012, I want to say. And before that, the API and the language was greatly in flux. This was written before December 2012, so it doesn't work with Go programs that have been written recently. It's only compatible with Socket.io 0.6 clients. The Socket.io protocol has been updated since then. It's grown. It's a lot better. We're not using the latest and greatest of the protocol. Pusher.go is basic long polling support. It's simple to implement. It's a quick and easy way to add real-time support to pretty much any environment. But it needs some help. It's also not updated for Go 1, and it doesn't use channels. It implemented its own like built-in channel thing, which is kind of weird, and I'm not entirely sure how it works. So it does need some help to get up to that point. I'm not sure why you would be using long polling when we have WebSockets and other things like that, but you know, I'm not here to judge. And so that's kind of a problem with our tools. That's the tools that Go community really has. That's things that we need new people to help out with and current people to kind of get on. But there is a problem with Realtime itself. There's a distinct lack of tools. And I'm going to tell you what I mean by that. There's a typical real-time architecture here. I totally drew this on my whiteboard and took a picture of it. This is high production quality, people. So you got your API or web server or whatever, something that's receiving information, and you got your WebSocket or push server. And that's something that's sending information back to the client and technically should also be capable of receiving information. So you got events happening over here, and the client is telling you, or is told about events over there. And does anybody see the problem with this? How do they communicate? We need this little purple arrow right here. And that didn't really turn out purple, did it? That's disappointing. So yeah, we need a purple arrow there. And you might be saying, you know what, a TCP connection. It's pretty easy. We know how to connect to computers. But as you grow, you need to horizontally scale these things. So now how do we connect them? There's no real sane way to do this yet. Well, sort of. We need a better solution for it. But Socket.io, you'll say, that's a framework, not a tool. Go is really built for creating tools. It's a systems programming language. It really likes the idea of binaries that do these one things really well, but don't try to encompass an overall solution. I think the difference between a framework and a tool is something that lets you help build outwards from your idea, whereas a framework gives you structure and you just kind of fill in the blanks with your program. We like a lot better the freedom of having tools that help us build instead of frameworks that we build within. That's not to say Socket.io is a bad framework. It's not to say that you shouldn't use Socket.io. People who wrote Socket.io are much smarter than I am, and I've had the good fortune to meet most of them. They're very smart dudes. But sometimes you want a tool instead of a framework. And that's my problem. I was building a real-time system in Go, and I didn't know how to do this communication. I searched around, and I eventually ended up writing something for it myself, and that's Peter and Wendy. And it's a solution modeled after Pastry and Scribe. Pastry and Scribe are these two algorithms that came out of the Microsoft Research Labs. Pastry is a distributed hash table that allows you to organize a set of cluster of nodes, which are basically servers in my use case, and have them kind of organize themselves so that they can communicate. Scribe is built on top of that to create a publish-subscribe network that operates a little bit like a phone tree, where you register your interest in the topic and then are notified of it. It is distributed. Given the IP of a single node, new nodes can bootstrap their way into the cluster. So you can have a new node in your cluster, just tell it about an existing node, and then it'll know about all of the nodes it needs to know about to join the cluster. And it is publish-subscribe. You declare your interest in the topic, and then when people publish to that topic, you receive all of those events. But we do need help with this. I wrote it myself in my spare time as well. It uses JSON as a message encoding instead of BSON or a binary safe format. So if you're trying to communicate with binary data, you're going to have problems. You're not going to have a good time with that. It does lack automated integration tests, and it really bothers me that my testing for this is basically all of the little pieces of the algorithm that happen within one server, and then firing up a bunch of these servers and just watching what happens and hoping it works. So we need some help with that. It's vulnerable to man-in-the-middle attacks in an unsecured network. I developed it for use in a secure network, but technically it could be used in an unsecure network that gets distributed to client machines, that gets sent around to different data centers, and you want more security for that. So it does have a very simple security model right now, but I'd like to implement something like a TLS handshake for it. It is yet to be deployed in a production environment. That's probably its biggest flaw. It works. It looks like it works at least, but we're still in active development and testing on it, and it needs a bit more before it's ready. NSQ is a solution from Bitly, who is also a big Go user. It's mostly decentralized. They have a bunch of these daemons. One is the NSQ lookup daemon, and it's a discovery service that can be run on many nodes, and then like your subscribers subscribe to the lookup daemons, the producers tell the lookup daemons about things, and you kind of send messages that way. It does have configurable behavior. You multicast or load balanced routing, so you can kind of decide how you want your messages to get delivered. There is a great high watermark feature that will, when you hit a certain amount of memory, will move messages from your memory to disk transparently, which is really cool if you got a lot of messages building up for a spike. And it's really mature. There are a billion messages that are served from Bitly's high performance infrastructure. They use it for statistics for their links. Messages are guaranteed to be delivered at least once. You do need to make it idempotent, so if it's deleted more than once, if it's delivered more than once, then it's not a problem for you. They do have really great StatsD integration, so you can track how many messages are being sent and delivered. It's got a great HTTP administration interface, and there are client libraries in multiple languages. It is an open protocol, so you can kind of develop clients for it in whatever language you choose. And finally, the third solution I found for this was IronMQ push queues. I do work for INO, so take this with a grain of salt. They're hosted queues as a service. They're highly performant. You get 100 million messages every day have been passed through this service. We get billions of them a month. So it's not going anywhere. It's not going to break on you. It's configurable. You can do a push or a pull queue. You can't do both, unfortunately. You can have unicast or multicast. You provide HTTP endpoints for us, and we will either send it to one endpoint at random, or you can have it sent to all of the endpoints. And if your endpoint returns an error, then we can have a configurable number of retries, and you can configure the delay between each of those retries. So it's highly likely that your message will get delivered. It's flexible. You can send from Go, Ruby, PHP, Python, Node.js, curl, its basic HTTP API, and you can receive on any HTTP endpoint. The downside of this, of course, is that you need to expose your message handling logic on a public HTTP endpoint because they need to be able to receive from our infrastructure. We do have a set of IP ranges that you can open, for example, on AWS to receive from those HTTP endpoints and nobody else, but it's a little bit more of a setup. So my point is really that Go is real-time. Concurrency and real-time go together, and Go is the best language I have found for creating clear, concise, real-time or concurrent programs. But I think Go could be more real-time, and I don't think it's a problem with the language itself. I think it's a deficit in the community. So when I present this in France, I'm presenting to the kind of best and brightest of the real-time community that Europe has to offer. And not right now, I'm presenting to the best and brightest that the real-time community is going to be receiving in the future. So I want you guys to check it out, the gopher. Look how adorable it is. This is the cue to awe. Aww. Oh, you played along with me, that's awesome. The gopher wants you to help out. And there are a bunch of resources you can get going. I had to make one Go pun. You can try.golang.org as a live tutorial almost, where you can learn about these concepts and run them right in your browser and get feedback from it, which is really cool. I love try.golang.org. Every time someone asks me how they should learn Go, I send them that way. Golang.org is the site for the language. It's got a bunch of articles, documentations, stuff like that. And Golang Nuts at googlegroups.com is the Golang kind of mailing list, where again, internet legends and people who are really smart, like Keith Rarick from Heroku and a bunch of the Bitly guys, they all just hang out there and they're happy to help you. So if you have any problems, feel free to email the list. I'm there as well. I probably won't respond to you because if you have problems, then they're probably above me. But yeah, so that's Go. That's why I think Go is real time, and that's what I think Go needs to do to become more real time in the future. Are there any questions? You're all staring at me. This is really uncomfortable. All right, what do we got in the back?
Okay, I may have missed it because I had to go to the bathroom, but what would you recommend like using Go for? Can you use it for software or anything, specifically for websites or?
A lot of the use case it gets right now is out of websites, just because it's got such a great net HTTP package. But a lot of people don't use it for websites at all. Google originally developed Go as a systems language. So if you're writing a quick command line utility, you can use Go for that. If you're writing a distributed, system like I did, you can use Go for that. HTTP is just one of the many things Go does really well. But if you're writing any kind of program, I would use Go. The only things that it does not have are a UI kit, so you can't do windowed programs. If it's from a CLI, you're good. Otherwise, you're probably out of luck or need to embed your own server with it. But other than that, yeah, pretty much anything. I reach for it with API clients. I do HTTP servers with it, distributed systems, CLI kind of tools, pretty much anything. Let's move our way forward.
Can I integrate my Java code or just say C code and also include the Go code into that? Can I integrate both of them or?
You could. It's a little bit more work. Go does have this thing called CGo, in which you can inline your C code with Go code and kind of have hooks from there to there. I haven't used CGo a whole lot. From what I understand, it's really good. But you should be able to do that. Java is going to be a little bit more difficult. It's going to be like communicating with any other language. You're going to have to communicate over sockets or something like that. You're going to have to find a way to inter-process communication with it.
Right, because for building websites, I think if I use PHP and then for creating server sockets, so for communicating it's good, but for building websites, I think if I could include this Go code in my PHP code or something like that.
Right. You can run it, so I know PHP has a way to run command line utilities and stuff like that. You can run it just as a regular command. That's one of the great things about having it be just a single binary. So you can just execute the binary and get the results. That's a little bit limited in ways of kind of using it. What I've seen a lot of people do is you create like a Ruby on Rails website for the interface of it, and then have a Go backend for like the API or things like that. Go does have an HTML templating library. I've seen better, I've seen worse. I think it takes a little bit getting used to use it. But yeah, so that would be what I would recommend. Any others? Yes.
So I heard you talk about a few use cases, but what are some more use cases for like channels?
Channels, a lot of the ways that I've seen them used, I used them as a control structure, so that, for example, in the distributed hash table, I needed to get certain access to like slices and maps. I needed it all to happen on a single Go routine to keep the concurrency safety of it. So I would pass in the request using a channel, and I would pass out a response using a different channel. Then I could send in a kill list using the channel to shut down the server, and different things like that. I've seen channels used to process the HTTP package actually uses channels to process your responses and things like that. There are a lot of different use cases for channels. It would really depend on what you're building to be more specific with it.
But it's used quite a bit, I assume.
Oh, absolutely. It's one of the main primitives in Go. So anything that whenever you need to communicate between two processes, you use a channel for that. Anyone else? Yes.
So how good of a job do channels do of eliminating things like race conditions? Like, does Go eliminate some of those pain points of concurrency?
It does. There are race condition testing tools that were released with Go 1.1, for example. That you do still have to be careful about something. It does have a spec online that you should read the memory safety kind of guidelines there. Typically, if you're accessing a shared resource, if you've got something like a global variable and you're accessing it from multiple Go routines, you should use a mutex to lock it and unlock it. And then they've got some things in the sync package that are like basic integer incrementation, so that you can increment things using just the command line instead of locking it, incrementing, unlocking it. But yeah, you do have to be careful about how you access that shared memory, because again, it's not built for sharing memory, it's built to communicate, and then they added shared memory if you absolutely can't avoid it. Make sense?
Yep.
You gave me a kind of there.
Yeah, I mean, I'm assuming so channels, like the idea of that is that like, you're sending one datum over, and then
Yep.
once you retrieve that, you just move
Yeah,
on.
you send one data over, and then that data belongs to the other process. Now you have no way to modify it. So that if you send it through a channel, you're safe. If you modify it without a channel, then you're in trouble.
Okay.
Make sense?
Right.
Yes.
And then I guess a branch off of that. Does that mean that the data is being duplicated? Like unlike a pointer where you'd be pointing to the same memory address, are you basically duplicating the data and then sending it over the channel into another memory location?
It would depend on the data you're sending. For example, slices, which are like lists, are just a pointer internally in their implementation. So if you send that over a channel, you're not going to be duplicating it. However, and pointer types, obviously, because Go does support pointers, pointer types will not be duplicated, obviously. But value things like strings will be duplicated. When you go convert from strings to an array of bytes, for example, you duplicate. And Go is passed by value by default, so that's its only kind of way to pass information. So even your pointer types, you're going to be passing the value of the pointer. So you're going to be duplicating that information, but that's all you're duplicating at that point. Does that make sense?
Yeah.
This is not my core competency, so. Yes, in the back.
Yeah. When you talk about the communication between the two servers, so Go, at which layer the Go provides the concurrency? Is it at the application layer?
Sorry, what was that? I'm sorry.
When I talk about the communication between the two servers, then
Yep.
I guess you talk much about the HTTP. So I guess this Go provides most of the concurrency at the application layer, which is specific to the server.
Specific to HTTP, Go does provide much of the concurrency for you.
So this
Each request is considered its own process at that point. Does that make
so
sense?
It's mostly related to the server specific, because when you talk about the network between the two servers, most of the concurrency is provided by the network layer or a transport layer. So this provides concurrency at the HTTP application layer. So what's the difference between the Java and the Go? Because Java can also provide a concurrency at the application layer, which is specific to the server. So what the spatial this Go provides in order to provide this concurrency?
What's special between Go versus Java is that Go provides better tooling to communicate between those two processes. So you're saying that in the networking layer, you've got that concurrency already. So Java and Go, yes, they both can serve basic HTTP pages using requests, but Go has better tools. For example, if you want to keep track of how many pages are being served right now, Go has a better idea of how to keep track of shared resources between those pages. If you've got person 1 and person 2, and person 1 modifies like a shared resource like a counter or a configuration value, there's a way for you to do that concurrent with safe concurrency in Go, whereas Java I think would be harder to do. Does that make sense?
So I guess the Java does it shares the memory before communication. So Go does in another way. I guess it communicates before it shares the memory.
Yeah, Go doesn't like sharing memory. Sharing memory is something that you try and avoid in Go. We try to send that communication through a channel instead of sharing the memory itself. Does that make sense?
But why is that? Because it provides a more overhead.
Yeah, we do that because it's a lot easier, I think, to build concurrent applications in that way. It's a lot easier to detect and avoid race conditions in that way. Does that make sense? I think it's a nicer abstraction for sharing things. Because if I give you a shared resource, I hand it to you, and then it's yours, and you hand it back to me when you're done, right?
I'm not really convinced, because that can happen, that can easily be avoided by the locking mechanism in the Java.
Right. You can do that with locking, and Go actually has locking tools as well. So yes, you can do that in Java. It's a little bit trickier to do that in Java. It's not as, I guess I'll go back to my statement earlier, that in Go, the simplest way to do something is usually the right way to do something, whereas in Java, it's simpler to not lock things, correct? Well, it's simpler to not implement that mutex and that locking, right? Because then you have to write the extra code to implement that. Whereas in Go, you have to just have the channel and send on the channel. That's the simplest possible way to share that memory.
So it's easy with respect to the developer.
Right.
Application developer. As a user, I don't think it provides a great difference between a Java and Go.
Right, I think the end user, the person making the request, isn't going to tell the difference between Java, Go, PHP,
So it
Python.
doesn't provide any performance increase over the Java. It's basically easy interface for a developer to build up the application. Is it?
The performance, I would have a lot of hesitation in saying it doesn't provide any performance benefits over Java. I think it really depends on what you're benchmarking and what you're doing with it. Benchmarking is a hairy beast that gets raised in the Go for mailing list every so often. At one point we had people say Node.js was several times faster than Go until one of the Node.js authors came into the mailing list and said, really all you're saying is hello world, so Node isn't actually doing anything. All you're saying is C is faster than Go, and everyone knows that already. It would really depend. I would be interested to see specific benchmarks. I know that, for example, using WebSockets, Go can serve more concurrent WebSockets than Java can. Is Go faster? Is there a definitive Go is faster than Java or Java is faster than Go? I don't think so. I think Go is faster at some things than Java is. Does that make sense? Any other questions? I'm getting lots and lots of blank stares. Do you all have a basic idea of what Go is, how to get started if you want to use it, and why it's a good idea for real time? Does anyone have any Patty you suck comments? Nick
Patty, you
does.
suck.
Nick has Patty you suck comments. Alright, well, thank you very much for bearing with me. How did I do on timing there?
Like 20 minutes.
36.
36
Well, including the question is 36.
Yeah.
Really?
That's
wow.
That's what this says.
Yeah.
Good job.
Huh. I don't have to trim this as much as I thought. Alright. Do you have any other questions about anything in general? Because I think I didn't use up all my time I was supposed to use up here. Or did I? Oh, I did. Cool.
How have you found like the database tooling layer?
There's actually a really cool SQL built into Go. So it's like an SQL query creator and stuff like that. You still have to write SQL. It's not an ORM. But it's kind of a base underline that SQL things can be built on top of. So there's a Postgres driver, there's a lot of MySQL drivers, there's a lot of SQLite drivers. We've got Cassandra, we've got Redis, we've got Mongo. The MongoDB driver is really good. I found that if I want to use a database, unless it's something weird like Amazon's new database or something like that, generally I've got good support for it.
Okay.
And generally the maintainers have been really responsive about replying to things and kind of communicating with users. Anything else? Alright, I think that's my talk then. Thanks. Oh, you yapped. That makes me feel really good. If anyone wants to see the talk, there are links in it and stuff. It's going to be online at ub.goonaboat.com. Go on a boat is because I'm giving this talk on a boat in Europe. So go on a boat.